friends, this is Kruti Jaipancholi, Assistant Professor in LJ Institute of Engineering and Technology in Department of Electronics and Communication. This video is about subject fiber optic communication. So friends, till now we learned about the various aspects of the fiber optic communication. So in this video, we will learn about the few more aspects of optical fiber communication. So in today's video, you will learn about WDM concept. Now friends, you know about what is the WDM. It's a kind of the multiplexing technique. Multiplexing is divided into the two parts. Analog multiplexing, digital multiplexing. Analog multiplexing is further divided into the two parts. That are the frequency division multiplexing and the wavelength division multiplexing. So in today's video, we are going to discuss about the WDM concept. WDM, wavelength division multiplexing. Multiplexing the different wavelength and transmitting over the single communication channel and separating out the channel at the other end. So in the WDM, why require? So whenever we want to increase the capacity, you want to upgrade the capacity without adding the new fiber. So at that time, using the multiplexing technique, we can improve the capacity, transparency. Each optical channel that can carry the transmission format. So different optical channels that carry the different transmission format, they have the different bit rate, whether the signal is the analog or the digital. So that kind of the transparency we achieve using the WDM. If the wavelength increases, the frequency of the signal that decreases. Now, how to get those fundamentals over here? So we can go for the use of the prism, which can turn the different wavelength into a single line, and that can be used at the output of the mux as well as the input of the demux. We can use also the scalability. When buy and install the equipment for the additional demand as needed. For the wavelength routing and the switching wavelength is used as another dimension to time and the space. The wavelength division multiplexing, that's an analog technique in which the many data streams of the different wavelength, they are transmitted in the light spectrum. Here you can see the diagram of the WDM. This WDM, you can see at the one end, the various wavelengths are there. It's a lambda 1, lambda 2, lambda 3 and lambda 4. And these all the different wavelengths multiplex by using the multiplexer. It is transmitted over the single fiber. And the single fiber can carry all the different wavelengths which can be separated out at the other end. That's a demultiplexer. And which will separate out the channel, and we have the lambda 1, lambda 2, lambda 3 and lambda 4 at the output end. So this way the WDM concepts that can be used for using the bandwidth efficiently. Here you can see the diagram that is for the use of the prism at both the ends. You can see that the various colors of the light having the various wavelength. These are wavelengths that can be combined by the multiplexer. That's a prism. And you can see all the combined light output, okay, and which is received by the prism. Now the another prism at the other end will separate out the thing. Friends, in your mind, there might be the question that how the prism will combine the light as well as how the prism that can separate out the light. So in this, the basic fundamental that is for combining and separate outing the lights, that is the refraction. So the refraction, that is the fundamental that used over here. We will study the refraction in the later, but I'll give you the idea about what is refraction over here. That is the refraction, that is while the wave which is travel from the one medium to the another medium, the light that can be either bended, okay, or the refracted. So that refracted light setting the angle of the refraction, we can get the multiplexing of the output. So the refraction, that's the main fundamental that's used over here. That the signal, okay, in the air medium, okay, rare medium. The prism, it's a glass, so it's a denser medium. So while the light will come from the air medium to the denser medium, okay, the light rays that can be bended, okay, and now what happened? That it goes near the normal axis, so it combines. Now while the light from the communication medium to the prism, okay, and prism to the air, mean that prism is the denser medium, so denser to the air medium. So the light rays that goes away from the normal axis, so it comes near to normal axis, it goes away from the normal axis, and we can have either the multiplexed output or the separated output at this end. So this way the WDM concepts that can be more useful in the optical fiber communication. Here we have the other diagram of the WDM. You can see that the lambda A, lambda B and lambda C. The wavelength of the different light can be multiplexed by using the multiplexer, combining lambda A, lambda B, lambda C, and the demultiplexer separate out the light lambda A, lambda B, lambda C. Okay, so this way the multiplexed output that can be used. So the WDM concepts, that is a number of light sources are used. Each light source emits the light of the different wavelength. Optical multiplexer is used at the input side to multiplex these signals. Okay, as well as the multiplexed signal is transmitted by using optical fiber. The detector is not capable of separating this light, and that is why there is the use of the demultiplexer, that is to differentiate the signals of the equal amplitude. So this way the WDM that is used. Now the improved version of the WDM, that is the bidirectional WDM. As we know that from the one end, the transmitting end, we can transmit the signal, different wavelength signal, and combining the signal and transmitting over the single medium. Similarly, the other end can be used at the receiver. So in the bidirectional WDM, the concept is, can we transmit or receive the data from both the end? Yes, it's good. So the solution is the bidirectional WDM. Over here in the diagram A, you can see that the transmitter at the one end, receiver at the another end. The transmitter transmits lambda 1, lambda 2, lambda 3 and lambda 4. the receiver will separate out the lambda 1, lambda 2, lambda 3, 4. Another diagram you can see that. From this end, we can transmit the signal lambda 1, lambda 2, lambda 3, lambda 4. Combining all the light by using the multiplexer, the transmitting over the fiber. At the other end, you can see that separate outing lambda 1, lambda 2, lambda 3, lambda 4. So now, can we transmit or receive the signal from the both the end? Yes. So we should go for the use of the device. It's a transceiver. So we can go for the use of the transceiver. So transceiver will transmit as well as receiving the data. So here lambda 1, lambda 2, lambda 3, lambda n. From either of the direction you can transmit or receive the data. So it's the good example and the good thing concept that is used in the optical fiber communication. So this is about the concept of the WDM. Now the advantages of the WDM. Because of the lower bitrate, the distance limit due to the chromatic dispersion is much larger. The transmission capacity can be increased by adding the additional wavelength, as well as it can be the transparent system and allow different wavelength at different bitrate. So WDM that may be preferred in the TDM in designing the more complicated network. The disadvantage of the WDM, that is, WDMs are generally not suitable for the deployment over the dispersion shifted fiber. Again, it requires the specially designed amplifiers that provides the flat gain. So, this is about the disadvantage. Also, it requires a separate terminating equipment for equivalent of each channel. The transparent WDM system that offers the less monitoring and network management capability. Okay, also it can be also useful for the optical fiber communication to merge different wavelengths into a single light for the communication. So this is about the WDM concept. So friends, thank you very much everyone.